Second test we're doing is the solubility test. So first one, we've got two different solvents we can use. We're going to use water. If we use the sodium hydroxide, we're only going to use the sodium hydroxide for those substances that were not soluble in water. If they're soluble in water, we will not attempt to dissolve those in the sodium hydroxide. So what I'm going to do is put about 3 mL of water first. We'll test that first, and then maybe about 5 or so drops of the liquid, about close to 1/10 of a gram of the solid, and then we'll mix thoroughly and see what happens in terms of solubility. And I'm just going to go ahead and just add about the same amount of solvent to each tube. Now sometimes when you're using a liquid, if they say to add 5 or so drops, sometimes you really need to add more than that, because especially if it's not soluble, because you really may not know if what you see is the sample forming that layer on top, or is it the meniscus. So I'll probably add more than the 5 or so drops, because if there is a layer, I want to be able to see it. And I think you can tell by looking, there is a layer there. So if I see 2 layers, then that tells me that this particular alcohol is not soluble in water. I'll do the same thing with our second sample with this benzyl alcohol. Sometimes if there are 2 layers that will form, sometimes it takes a few minutes for you to get complete separation. But I think you can tell that there is a layer that is forming on, that we see on the top. Actually, in this case, it may be on the bottom. Let's let that sit for a few minutes, and then we'll come back and take a look at that. Yeah, this particular one looks like the layer, we're going to get that smaller layer on the bottom. We'll let that sit for a couple minutes. I want to go back to the first one, and you can certainly see that second layer. But let's let this sit just a minute, and then we'll come back and take a look at it. And I think if you look at the bottom, you should be able to see kind of like looks like a circular disc there at the bottom. And that's the sample that we added. Remember, we had a lot more water than we do of our sample, but you can see that there's a little layer on the bottom. It's almost like a globular type formation. And why is it on the bottom? Because the benzyl alcohol is more dense than the water, so that's the reason we see that. But you can certainly see 2 distinct layers there. So that one is insoluble. Next one, we're going to add benzoic acid. And when I look at that, I'm really not seeing much of a change in terms of the amount of solid that I started with, so I would say that that's pretty much insoluble. The next one is salicylic acid. Again, I'm not noticing much dissolution to take place there. You can kind of see we still have some that's on the bottom. We've got some that's still stuck on the sides of the test tube, so water insoluble there. Unknown number 1. We'll let that sit for a second. I'll come back to that in just a second. And I think you should be able to see that thin layer up at the top. So again, insoluble. Now, if we're trying to figure out if that is one of our knowns, remember for the first one, that layer was on top. For the second, it was on the bottom, so we can kind of identify which is which at that point. And then for our last sample, unknown 2, put that in water. And then we can see that the solid is really, none of it has dissolved, it looks like. So all of these appear to be insoluble in water. The next part of the solubility test, since all samples were insoluble in water, we need to test them for sodium hydroxide. So what I'm going to do is put about the same amount of sodium hydroxide into these tubes as we did for the water. So we're going to add, for the first test tube, our known isobutyl alcohol. Just let that sit just for a few seconds. I think you can see the top layer there. So it's not soluble in the sodium hydroxide solution either. So we'll take some of our benzyl alcohol, put several drops of that solution. And again, we'll let that sit for a short period of time. And I think you can see that it's almost emulsified in a sense, but you can start to see how it's wanting to separate. It's not a one layer system, so we're going to say that's insoluble. To our third test tube, we're going to add the benzoic acid. And as we look at this solution, this was the benzoic acid dissolved in the sodium hydroxide. It looks like all dissolved. Next one, we're going to do salicylic acid in test tube 4. Small amount we'll add to that. And it looks like this also dissolved. I don't see any particles floating in. And then for next test tube, our unknown one. Just give that a second to separate if it's going to. And you can see the two layers. So insoluble in the sodium hydroxide. And then our last unknown. And looks like all of that also has dissolved. So what does that mean? Let's think about that for a second. So in terms of solubility, and we know we were dealing with alcohols and carboxylic acids based on the name. So if I'm looking at the alcohols and they were not soluble in water, then most likely they're not going to be soluble in base, which is what we saw. And the reason for that is those alcohols are too weak of an acid to react with the sodium hydroxide. If they do dissolve in the sodium hydroxide, that would really be a chemical reaction between an acid and base. So it doesn't surprise us they're not. Why were they not soluble in water to start with was because of their size. If you get 4 more carbons, again, water solubility starts to go down quite a bit, and that's what we're seeing. When we take a look at test tubes 3 and 4 with the benzoic acid and salicylic acid, those compounds are acids and they've got that carboxyl group on there. They can hydrogen bond with water, but because of their size, they're not soluble in water. But because they're acids, they were able to react with that sodium hydroxide in solution. And then our unknown one, since we see that it wasn't soluble, we're assuming it's got to be one of these alcohols that's higher molecular weight. And if we base it on what we saw in the first two, we would assume it would be isobutyl. And then here, since this dissolved, I don't really know which one it is, but we're thinking it's one of those carboxylic acids. So the next test we're going to do is the Ceric nitrate test, and remember this picks out whether or not you have alcohols or phenolic groups. So what we're going to do, this is our blank. I put about 3 ml of water and about 10 drops of the reagent. I've already got the water in the separate test tubes, so what I'm going to do is go back and add the Ceric nitrate to each. Once I've done that, then we'll add our sample and then observe if there's any change of color from what our standard is. And before I add the samples, I'm just going to give each of these a little shake there. And then I'm going to go back and add about 4 drops or so of the liquid and just a small number of crystals of the solid. So isobutyl alcohol is first. And we can see that we've got a reddish color there, so that's certainly different than what we started with. So that's indicative of an alcohol present. Next is benzyl alcohol. You can certainly tell that there is a color change. Now, it's not unusual because the benzyl alcohol may not be that soluble in this reagent, but even if you get a separation of layers, the whole mixture doesn't have to have color. Sometimes you may just see it in one layer or the other, but if I see any type of color change, then that would be positive for an alcohol. We've got our benzoic acid. Not really seeing much dissolution, but notice there's no color change either. So we would say that's negative. The other thing I'd like for you to do, if you do see a difference in the color, although these look the same, pretty much the same, but if you did notice a difference, I would state what that difference was. Next is salicylic acid. Now, salicylic acid, and if you notice, it looks like there's a change, a little bit of a change taking place there. Remember, the ceric nitrate would be positive for phenolic alcohols and also your non-phenolic alcohols. Notice there is a difference in what we started with. So it's picking up that OH group that's attached to the benzene ring. Next is unknown 1. And notice you're seeing that kind of reddish color, so positive for an alcohol. And then our last unknown. And this might be the first place that we actually can decide maybe what our unknown is. We'll see. So we've added unknown 2 to the last test tube and stirring that. And if you notice, we still have some that didn't dissolve, but I think you can tell a difference between this and this particular solid, which was the salicylic acid. This was the benzoic acid. So I think you can identify what your unknown 2 was.